All right. Good evening, everybody. Calculus increasing and decreasing functions. This is the start of a new kind of look at derivatives and things like that. So, the first thing we want to do is just cover some basic ideas of what it means to increase and decrease. All right. So, if I have kind of a rough graph here. This is a little bit better than the ones in our book, just because it has kind of the points kind of drawn on the graph, and so this might help us kind of better understand what's going on. All right, so what I want to do is I'm going to kind of talk about this. We'll notice if we look at this function that it is increasing like I said, a roller coaster, and then it reaches a peak. We call this a critical point because you'll notice that the instantaneous rate of change at this particular point, if we notice the instantaneous rate of change at this point, or the tangent line, the slope of the tangent line, is equal to 0. And that will come into play here in just a little bit, but for right now we're just kind of looking at the graph. All right, so if I look at this, I would know that the function is increasing from negative infinity to, in this case, -2. Okay, now this is very hard to realize because if you look at this, we're not talking about y's. We don't care about y's. We're just talking about the domain. So as x is coming from the left, from negative infinity, it is increasing, increasing, increasing. Then when it reaches -2, it stops and it changes direction. So this kind of talks about negative, where it is negative. Ooh, that's a bad spelling there. Sorry, negative. All right, and on this one we have, I'll kind of draw this in red. Here, I'll just draw it in red. So this thing is negative during that point. And again, we have another critical point here where the instantaneous rate of change is 0. We call these critical points. All right, so now I can state where it is decreasing, and that would be from -2 to +3. So during this little segment between -2 and +3, it is negative. And then finally we have one more little stop here in which we're going to then be increasing, which is between the points 3 and infinity. Okay, now again, make sure this works out nicely because we're thinking, oh, it's going up to infinity, but what we're talking about is the x. So as it continues this way, okay, it's going to, as x approaches infinity, or as x gets to infinity, it's going to keep increasing, increasing, increasing. Okay, so that's kind of a basic idea of the increasing and decreasing functions. Now what we're going to do is talk about the nuts and bolts of this idea. Okay, so I've kind of written out some different things here. We've identifying critical points exist where the derivative of the function equals 0, and we can determine where it is increasing by plugging in a number into the derivative. And so if the slope of the tangent line, or the instantaneous rate of change, is greater than 0, then we call it increasing, and vice versa. If we plug in a number into the graph and we find that the instantaneous rate of change, or the slope of the tangent line, is a negative number, then it is decreasing. Okay, so if that was a lot of jumbled stuff and this kind of looks a little awkward, don't worry, I'm going to run through this example 2 real quick, and we're going to kind of talk about that. All right, so example 2, we have f of x equals 4x to the third minus 15x squared minus 72x plus 5. Okay, so what we're going to do is use our power rule here. It's just a basic polynomial. So the derivative of this is, let's see, 12x squared minus 30x and minus 72, and then the 5 is a constant, so it is 0. Now, before we start factoring this thing, something that some of us love and like to review occasionally is, let's factor out a, let's see, what's a common denominator here? I think 6. I think 6 can go into all these pretty evenly. So if I factor out a 6, I get 2x squared minus 5x minus 12. And so the reason why I do that is that you still get the same answer, but it doesn't have as large numbers. Okay, so now that I've kind of simplified the derivative, let's now find critical points, which is going to be up here. We're going to set this thing equal to 0. So 2x squared minus 5x minus 12 equals 0. I'm going to divide by 6, which would eliminate the 6 out in front. So if I divide both sides by 6, that gets rid of that. And so I'm left with 2x squared minus 5x minus 12 equals 0. Okay, so now I need to find two factors of negative 24. negative 24, that when added together are going to equal negative 5. To do this, kind of top it off the top of your head, negative 8 and 3, so I have x minus 8, x plus 3 equals 0. We divide by 2, and we are left with x minus 4, x plus 3 halves equals 0. Okay? Woo! That's just a nice review on pretty much a lot of algebra there. Okay, again, we found the derivative. We factor out a 6. We found the derivative. We set it equal to 0. Then we just solved the polynomial. So our two solutions are x equals 4 and x equals negative 3 halves. All right. So we're doing good here. Now, these represent our critical points. Okay, so I'm going to erase this real quick just to make some room for me here. Write that down there. Or give me just a second. I'm going to keep that this up here. I'm going to keep the derivative because I think that's going to be important for us to reference to quite frequently. And give me a second. 4 and negative 3 halves. All right, I kind of forgot where my critical points were. All right, so we found earlier that when the derivative equals 0, it came to 4, and x equals negative 3 halves. Let me make sure. I have a terrible memory. I'm getting old. Gosh darn it. Sorry if you're negative 3 halves, yes. All right, so I'm making sure I'm right there. All right, so I'm going to draw the graph here. And I'm going to draw those critical points. Again, those are where the derivative equals 0, okay? So I have found these kind of turning points in a way. So we have 4, 3, 2, 1, 0, negative 1, negative 2, negative 3, and I can kind of keep going, but you guys get the idea here. Let's have 1, 2, 3. Okay, so I know my critical points. Let me mark those in blue are 4. And my other critical point is at negative 3 halves, which is negative 1 half. Okay, so now what I want to do is I'm just going to test some points. Now again, I want to plug my points into the derivative. So if I do this, I'm going to plug in, let's say, negative 3. I notice negative 3 is on this side of the line, so I'm going to test that point. On this one, I'm going to test 0. And here I'm going to test 5. Okay, make sure we're plugging it into the derivative. Okay, so now we need to find positive numbers. So what I'm going to do is bust out my calculator here, and I'm going to plug this into the y equals. All right, I'm back. Turn on the light here. So we have y equals the derivative, so that's what we want to put into the function. So we have 12x squared. 12x squared minus 30x minus 72. Okay, so if we do that, we look at the table here, and I notice that when it's negative 3, it equals 126. So let's talk about that, 126. So that means that it is increasing during this time. If I plug in 0, that means it is negative 72, which means it's decreasing at that time. And then if I plug in 5, I get 78. So it is increasing at that time. Okay? So I have these nice little graphs here. Now my final part on your assignment was to determine whether it is increasing or decreasing. So this is part B. It is increasing from negative infinity to negative 3 halves, and also is increasing from 4 to infinity. And then also, it is decreasing from negative 3 halves to 4. Okay, so hopefully you got those same results. You can see on the paper that there's a lot of stuff here, and I even erased some stuff to get this all fitted on here. But it's important to kind of walk through steps. It has general steps, and the book kind of gives you a nice layout of the steps that you need to do. So let's review those real quick. You're given a function, find the derivative, set it equal to 0, find the critical points. All right. Then test some points that are in each area. So like negative 4, I plugged that in and got, I guess I plugged in negative 3, I got 126. I plugged in 0 and got negative 72, and then I plugged in 5 and got 78. So that tells you where it's increasing and decreasing. Notice that we call it increasing because the instantaneous rate of change is positive, meaning it's going up. and here the instantaneous rate of change is negative, which means it's going down. Okay, so I know I'm kind of like these problems to explain everything. It's kind of a little tentative. Okay, so I apologize for that. But let me, I'll set you up on this next one, and then again, I know I always say this, but we're going to start with this one tomorrow. Okay, so finish this one off when I'm done. And we have f of x equals x plus 3 over x minus 4. So now we have to do the quotient rule. So if I quickly do that, find the derivative of that, that would be the derivative of the top one, the numerator, which would be 1 times the basic denominator minus the numerator times the derivative of the denominator all over x minus 4 squared. Now, that looks like a mess. Okay, so let's clean that up just a tad, and let's say that, all right, I'm going to kind of distribute this up here. So I have x minus 4 minus, now notice these both go to both of these, so it would be minus x minus 3 over x minus 4 squared. And so the derivative simplified would be, well, let's see, x minus x, which is 0, so those guys are gone. And then minus 4 minus 3 would be negative 7 over x minus 4 squared. Forget about that. That's nothing. Don't worry about that. So now what your job is to do is to find the critical points. Okay? Now critical points not only exist where x equals 0, but also where what x cannot equal, meaning the denominator cannot equal 0. So you have to figure that out. Okay, and we'll start with this one tomorrow. Okay, I'll start right here tomorrow, but please attempt it on your own as you go. Okay, thank you very much, and have a wonderful afternoon or good night or morning.